Okay, so this is the anatomy of bones at the cellular level. So I remember this first part by Pink Parrot Seems Super Mad. So the first function of bone is for protection of internal organs. And the second one is production of blood cells. The next one is support and structure and movement. And then your tarsal bones are short bones. Your frontal bones are flat. Your tibia is long, so is your humerus. Mandible is very irregular. Metacarpal is long. Radius is long. And vertebra is irregular. Now we're going to be labeling parts of the bone matrix. So this is your nutrient artery, and then your periosteum, then yellow bone matrix, and then your medullary cavity. Then up here you have your articular cartilage. Sorry, I had to make sure I didn't write articulate. Spongy bone, endosteum, epiphyseal line. Then up here you have your proximal epiphysis. And that's because that's proximal area. That's why it's proximal epiphysis. Diaphysis, your distal epiphysis. And then finally you have your compact bone. Then this is your caniculus osteocyte, lacuna, extracellular matrix. This is spongy bone, Volkmann's canal, Haversian canal, periosteum, lamella, osteon in the middle here, compact bones, all that, and trabeculae. Articulation is a condyle. Projections are epicondyles, crest, spine, tuberosity, and ramus. Holes are foramen, meatus, and fissure. Osteoarthritis is articular cartilage wearing down. Osteogenesis imperfecta is a genetic disorder that causes brittle bones. Osteomyelitis is an infection in the bone. Osteosarcoma is a malignant bone tumor, and Faggus disease is a metabolic disease. So now, osteoblasts are cells that produce bone matrix and build the bone. Build, blast, same thing. Bone-destroying cells are osteoclasts, and they are multinucleated. Osteocytes happen once an osteoblast is completely surrounded by bone matrix, becoming an osteocyte. Collagen is an organic material. Hydroxyapatite is inorganic. Collagen makes bones stretchy or flexible. Hydroxyapatite makes bones hard or compact. So an example of an endochondral bone is your humerus. Intramembranous example is a flat bone of the skull. Endochondral ossification is when inside cartilage, hyaline model is replaced by bone. In intramembranous ossification, centers grow together to make spongy bone, compact bone is laid down on the outside. Now this is a homeostasis example right here. Alright, so grown bones grow in length because chondrocytes at the epiphyseal plate divide and grow and then are replaced with bone. They grow in diameter because compact bone is deposited on the outer surface just below the periosteum. And this is oppositional growth. Let's see here. Okay. Epiphyseal plate, which is also your growth plate, becomes epiphyseal line when ossification is complete. And that's it. Thank you.